Hello. All right. Almost a full room here. I take it that you're all web developers. That's good. We're going to talk about optimizing websites today, ASP.NET and IIS. That's what it's all about. My name is Mads Christensen, and I work on the ASP.NET and Visual Studio team. And we're going to go through a lot of practices that are, some of them really easy to do, some of them a little bit more complex, but it's all something that you can go home and do on your own websites at the end of this. So this is very practical, and you can apply it to all websites. Like what I'm showing here applies to everything. If you have any questions as we go along, just raise your hand. I'll repeat the question so everyone can hear it. And I'll also leave a little time at the end for any additional questions that you might have. So, do we really need to optimize our website? Everyone's running on high bandwidth, 4G, LTE on their phones and so on. So is it really that important? Well, yes. Google, for instance, they ran a test that if they slowed down their search pages by 20%, or sorry, by half a second, they would drop 20% in traffic. Like Google makes money off of page views, off of traffic. That's how they have their ads, how they sell their stuff. So this is really, really important. 500 milliseconds drops 20% page views. What is half a second? What is 500 milliseconds? Well, you can probably feel that, right? You would think, well, half a second, I can feel that. I can feel like a slow page rendering. So that's something. So 500 seconds, we can notice that. But Amazon, they did another test. They slowed down their website by 100 milliseconds, a tenth of a second, just to see what would happen. And they lost 1% of their sales, their revenue. Now, if you're Amazon, then last year, their revenue was $75 billion. Okay? 1% of that is $2 million per day in lost revenue for a 100 millisecond delay on their pages. So you can imagine if you work at at Amazon, and you can optimize their website by 100 milliseconds, you can probably go and ask for a raise afterwards, right? This is important stuff. It really matters. And we can optimize various different parts of our website. Here's like a typical N-tier web app. We have our database. We can do indexes and partitions and all that sort of stuff down there. We have some data logic, and maybe there's some caching layer somewhere between data and business logic somewhere. And then at the very top, we have ASP.NET and the IIS web server. And that's what we're going to talk about today. We're not going to talk about how to do indexes on your database. Right? We're not going to talk about caching strategies on the server and all this sort of stuff. We're only going to talk about the topmost tier. And there's a reason for that. So here's a request tree. We've seen this in Fiddler and whatnot. So here's what's loaded on a website. At the very top, the bar you see there, that's our HTML page. That's probably where we have where we display data that we got from our database, right? All the other requests are images, JavaScript, and style sheets. So if we optimize our database, we're only going to be able to move and make the topmost bar a little bit smaller. But we're still going to have the tags of all the rest of the requests coming in, right? Delaying the time it takes for the page to load. So it kind of makes sense. And if we look at the top 50,000 websites, we'll see how that plays out. This is time spent in the browser. Only 13% are spent on the back end, on the top bar, on the stuff we get from our database and stuff. 87% is all front end. It's all the things that goes on between your web server and the browser, sending over images, JavaScript, CSS, and so on. So if we can optimize on the 87%, that would be a good thing. We should also optimize, of course, for the 13%, for the back end. But there's a lot more return on investment here on tackling the 87%. Now, if you run ASP.NET 4.5, you will automatically get a 30% faster startup time, and a 30% lower memory use just by installing 4.5. Even though your app is running 4.0, if you have .NET Framework 4.5 installed, it'll do an in-place upgrade of 4.0 as well, and you will get a benefit without having to do anything. So that's the one thing we get for free. The rest we have to do ourselves. So let's go do that. So I was showing you this website, the Web Developer Checklist, webdevchecklist.com. And it has a very nice little section for ASP.NET Performance. And we can now just go through this, and you can do this at home, and check off everything that you do until you get them all. And of course, there are explanations and links to how to do all these different things. And so this website is actually very, very highly optimized. So what I've done is I've taken this website and I've removed all the things we did to optimize it. I've de-optimized it, so to speak. So we can see how we can take a real-world website and performance optimize it. So let's just go into Visual Studio. And here's what the website looks like. It's very basic. Very basic. We're going to use a few tools here. There are two tools. I'm using Firefox for this. And there are two extensions for Firefox that are really, really good. One of them is Yahoo's YSlow, and the other one is Google's PageSpeed Insights. Anyone here know and use those tools? Yeah? Just a few hands? All right, these are your best friends. They help us analyze and figure out what's wrong with our website. And they're plugins to Firebug. So if we open the tools here, we can see this is YSlow. And if we just run the test here, we can see that we get a grade C and a score of 75. So 75 out of 100. This is not bad. It's actually okay. You know, think about the American school system. Right? If you get a C, you still pass, okay? But it's not an A. Right? We want to get as close to 100 as we possibly can. That's the goal. And it has like certain rules here. So let me zoom a little bit out. So we can see some of the things that it doesn't like. Some of it we get a nice A, and some of it we get an F. So F is definitely not a good thing. And we can sort of just go take them one by one. But let's just switch over here to PageSpeed. This is Google. Google have a nice little analysis tool as well. It's actually built into Chrome these days. But they have rules as well. Some of them are, here a warning, like something, you should probably do all the yellow ones, and if you do something really bad, it will be red. Okay, so those you should definitely fix. But then they have some here that says, well, it's actually okay, but you could do better. Those are all these ones that have, you can open up like this. Okay? So that's how those tools work. But if we take a look at what is our website, how does it look like? It looks like this. Whoop, wrong one. There we go. So this is what it looks like. We have two charts. We have one on the left and one on the right. The one on the left is the scenario where a user visits the site for the very first time. Nothing is cached in the user's browser. So the first time a user hits the website, the browser is going to download 12 artifacts, and it's going to be 107 kilobytes. The next time the same user comes in with the same browser, we have a primed cache, and we still have 12 requests, but only 40 kilobytes are sent over the wire. Now, for both these scenarios, we want to have both numbers, both the number of requests and the size in kilobytes, as low as we possibly can. Okay? So that's what we're going to do today. We're going to see if we can hit 100 on YSlow. There used to be a scaling system at Google as well, PageSpeed, where it also would give you a grade from 0 to 100, but they removed the score. So we're just going to make sure that everything is checked off and we're doing the right thing. And we should see these numbers go down drastically. Okay. So the first thing that we should probably take a look at is some of the easiest. Some of the biggest gains we can get from optimizing our websites are also the easiest ones. So that's pretty lucky for us. It used to be really difficult to do. I've been giving talks about this subject for the past 6 years or so, and it's gotten easier and easier and easier every year because of new tooling improvements and so on. So it's pretty cool that we can now very easily fix some of these issues. One of them here says we should use gzip. We should compress our text-based files, HTML, CSS, JavaScript. How many people here actively gzip their stuff on the server? Okay, that's not a lot of you. So let's take a look at how to do that. So on IIS 7 Plus, we can go into the web config and we can go into the system.webserver section. This section is specific to the IIS. This is where we speak directly to IIS. Not to ASP.NET, but to IIS. And here we can set URL compression to true. It is a very, very strange name, URL compression, because we're not compressing any URLs. But we are, in fact, gzipping our content. And gzipping basically means that we're zipping up our text-based files and then sending them to the browser, and the browser can unzip them itself. So we save a lot of bandwidth while doing that. So we made this change. Let's go back here, hit Control F5, and run the test again. So now we're doing a little better. We went from 75 to 82. Right here, right? And we get a B. So that's pretty good. By the way, chances are that if you have never looked at this before, your website will probably be around 50 or 60. Right? You will not pass the exam, basically. But this web, sorry?
The gzip that you just did, is that valid for pages that are A, completely dynamically generated, and B, never cached? Because they're data-driven, so they can't cache.
Yes. So the thing I just did in web config, whether or not that applies to both static and dynamically created pages, we have two settings here. Do dynamic compression. That means exactly your ASPX pages, your Razor views, and so on. They're dynamically generated on the fly, but because we set do dynamic compression to true, they will also get the benefit. So the server will on the fly gzip them and send them out. And so you might think, oh, what about like CPU of doing that? Is that a problem? No, it is not. You should always enable this stuff. The benefit of minimizing your files versus that little hit it will take on the server of CPU to gzip is completely worth it. It does not, it's like sub-millisecond it takes for the server to do this sort of stuff. It's been optimized over the years to do this super efficiently. So don't worry about that. Static compression is, well, static files, so any files that serve through the static file handler. Right? So just your regular .css and .js files, for instance. This guy, if we got time, we can talk about this one. It has problems. If you're doing cache, if you're doing output caching, you can play around with setting this to true. If, however, you are using HTTP modules that rewrites the response, you can run into problems. So just to play it safe, don't do this, but play around with it when you get home, right? This could really benefit some stuff, but just be careful. So anyway, we're doing pretty well. If we look at our statistics here, we can see that we lost a lot of weight. Instead of 107, we're now down to 58 kilobytes, right? Just by setting that one line in our web config. Now I actually cheated a little bit. If you're running on Windows Server 2008 R2, that means that you have IIS 7.5. What I just changed in the web config is by default, so you don't actually have to do that. But if you're on 7.0, IIS 7.0, you have to do what I just did. So I was cheating a little bit. So we lost some weight, but we still have the same amount of requests. And we're being told here that we have 6 external style sheets. Let's take a look at that. We see here, we do in fact have 6 style sheets. So what we can do here is that we can bundle and minify all this stuff. So take all your style sheets and basically turn them into a single CSS file. But doing it in a way so you still have the refactored multiple different files in your source code. So it doesn't hurt your the readability of your code or anything. And the way we can do that is that we can go into take our style sheets here, right-click, go to Web Essentials. Are you all using Web Essentials? Hands up, who's using it? Okay, so there's a lot of features in Web Essentials, which is a free extension for Visual Studio, that helps us optimize our website. One of them being we can create a CSS bundle file. So let's do that. And let's just call it my bundle, that's good. And now we get this file right here. I have to make sure that the files listed are in the same order as they were before in my page here. So we want normalize to be at the top. In Visual Studio 2013, we can just hold down the Alt key and do arrows up and down to move a line. So we're just going to move that guy up there. We're also going to set this to minify, so set this to true. I'm going to save this file. So we now have a few new files here. We have the XML file, that's this one that I just edited. And then it creates a mybundle.css. Okay? So now we can just go in here, take all this stuff, my bundle, I have that right here. Save that. Let me just show you what's in it. It's just CSS. It just took all the different files and combined them into one. Simple string manipulation here. And now when we reload our website and run the grade again, you'll see that we now get a score of 90. If it was 91, it would have been an A. So we're getting close. And we lost some requests here. We're now down to 7. So that's pretty good. We had 12 before, now we're down to 7. Without really doing anything, without changing our code really, right? Just a small little gestures. Yes, sir. Yep. So the question is, do I have to rebundle every time I make a change? No, Web Essentials will do that for you. So anytime you change one of the source files, it will automatically rebuild the bundle file. Okay? So your workflow doesn't change. Okay, so we're really good here. We actually lost a little bit of weight as well, like maybe half a kilobyte here. Because before we were sending 6 files over the wire, each of them has HTTP headers, right? So we now removed all of that except for HTTP headers for one file. So even though the content is the same, we got rid of 5 additional sets of HTTP headers. Yes, sir, down there. What's the best practice for doing bundling? To either use Web Essentials or to use some of the runtime stuff like the bundle config? Or MS Build. MS Build, there are tasks that will bundle and minify as well. There are no best practices. Like whatever works for you, whatever you like, it's a personal choice. The end result is the same. I prefer to do it at design time, which is the Web Essentials way, because that will keep my files statically on disk. I know exactly what's going on. And that's just my choice, personal choice. Okay. So we're doing good. We're doing good. Let's take the next one here. Add expires headers. So if we just look at the components we have, let's just see what it says actually. It says with all the JavaScript and the images and my one style sheet now, it does not have a far future expiration date. And that's because I haven't set any. By default, none of this is set. So if we just take a look real quick on our CSS here, for instance, we can see that we do, in fact, we don't have an expiration on this. So an expiration, that's an HTTP header we can set that instructs the browser on how to cache and for how long it should cache, in this case, my CSS document. Okay? There are some problems here. The cool thing, let's get to the problems a little later. The cool thing about this is when you instruct and you are very explicit, you say, hey, browser, cache this file for a year. What that means is that the browser will then never request those files again, okay, for a year. It will just serve them up from its internal cache. If we don't set anything, like it is right now, then browsers have their own heuristics and they just have their own logic of how they want to cache things. We want to be explicit and tell them, cache this for as long as you want to, or as long as it makes sense. And let's just go with a year. That's what the standard tells us. You can set it for 20 years if you want to. But let's set it for a year. And we'll get back to what the problem is with that afterwards. So these are all static files. So it was complaining about CSS, JS, and PNGs here. They're all served statically. And in the web config, we have a section just for that. It's called static content. And what I'm doing right here is that I'm saying everything that's static, served statically from the server, you should set the max age cache control header, and you should say that it should cache it for a year. So this is sliding expiration, whatever it is today plus a year. Okay? So now the web server will automatically add that header to all of our files. So let's go back here, Control F5, and let's try this again. Ooh, now we got an A and 94. That was pretty good. So technically we're done, right? When you get an A, we're happy. But of course, it doesn't work like that. Now let's take a look at what happened here. In our empty cache scenario, nothing changed. The browser will still download all the files. But on the right side, the prime cache scenario, we're now down to 2 requests. The HTML page and the fav icon. That's all the browser will now request from the server. Okay? That's really, really good. And that will be really fast too. Really fast. But the problem here is that when we cache something for a year, what's the problem? Exactly. What happens when you make a change to my CSS file, then the browser will not ask for the change, right? For a year. That's a problem. There's only one way we can get out of this mess. We need to come up with a cache busting strategy. To do that, we have to change the URL pointing to our CSS file and JavaScript and so on. That is the only way we can do that, because then the browser comes in, it loads the HTML page, and now it sees a new URL. And it looks in its cache. It says, well, I don't have this URL. Let me download it. But that would be kind of annoying to do that manually, right? Every time you make a change, go to your HTML page and change the URL. You can just add a query string parameter, right? !v version equals 5. That will work. But we don't want to do this manually. So instead, I have created a little helper function. So let's just call that. So this is Razor, so I'm going to go with that. Fingerprint.tag. Go. Now let's load this up again. And let's take a look at the source. The other way, here we go. Now look at this. What my function does is that it injects into the URL the date time ticks of when the file was last modified. So whenever I make a change, this just updates automatically. Okay? Super easy to do. Let me just show you if I can zoom out here. This is it. Okay? That's all it takes. So we're basically just reading last write time, and then we're injecting the and the date time ticks. That's it. Super simple. Now, how does this work? Like this URL does not exist, right? This folder, v dash and then a number, it does not exist physically. It's not part of my solution. So how does this work? Well, we have to do one more trick to make this work. And again, we can just use web config. So in the web config, we have URL rewrite rules. Anyone here played around with URL rewrite rules? Yes? Oh, sweet. Yep. Some of my favorite technology right here. And the cool thing about it, it's completely configurable from our web config. We don't need to touch any code for this. So I have a method here, or a rule called fingerprint. And so when a request comes into the IIS, it's going to look for my rule, and it's going to match on this regex. So this regex says anything, and then if you have a path that starts with v dash and then a number, and then something after that, then strip out the second parameter here. So we just have the first and the third. It just simply strips it out. And this happens on IIS. We're in the system.webserver section of the web config. This is not ASP.NET. This is IIS. Okay? So when the request comes in to ASP.NET and all that stuff, it has already been rewritten. ASP.NET doesn't know about this at this point when it happens. So we're really on the metal here, and it's really efficient. So that was just the URL rewrite, and now we have our cache busting strategy. So now it's safe, but you cannot set the expiration to a year and not do this. You have to do both. Okay? Okay. So that left us here. Let's see what else is the problem. Add expires headers. Oh yeah. So this is a funny one. Favicons. Favicons behave completely different than any other images that you've got because it's sort of a browser thing. It's not something that's in your page. It's displayed in the browser. Right? It's right here. This check mark, that's my favicon. So it doesn't follow the same rules. If I clear my cache like this and hit F5, every image and styles and all that will now be reloaded except for favicon. This is true in all browsers. For me to make any change to the favicon, I have to clear my cache as I just did. Let's just do that again actually. Clear this guy, close the browser, and reopen it. So let's see if that worked. It did. See, now we're down to one request here. Because now it picked up on the HTTP header that I put on my static files to say expire in a year. So that's cool. It's starting to look really, really good. There were some other things here. One of them is I have some JavaScript. I got two scripts. I got Modernizer and then my own script.js. And I want to do the exact same thing here by fingerprinting it. So let's just do that. Fingerprint.tag. Yeah, what's the reason for not using a query string parameter and instead doing the whole URL rewrite by injecting v dash datetime ticks into the path itself? There aren't that big of a thing, big of a change. The browsers will still update correctly and you will cache bust. This is for proxy servers. A lot of proxy servers, when they see a URL with a question mark in it, they will never cache it. So if you want proxy servers to cache as well, which you do, then you need to either change the file name or change the path. I opted for changing the path. Changing the file name would work as well, but you would, in any case, then you would still have to do the URL rewrite. So now we're fingerprinting our script here. We don't have to fingerprint Modernizer because it already has the version number in the URL here, so we don't really care about that. And should we bundle these two files? Should we do the exact same with JavaScript where we take multiple files and make them into one? Yeah, we could do that, and that's a really, really good idea, except when it comes to Modernizer. Modernizer is special. Modernizer have to be in the head of your document. Because what Modernizer does is that it helps older browsers understand the newer HTML tags, such as video and article and so on, and other things. But it has to load before the content of your page loads. So we have to keep it at the top. And normally, we have to move all our scripts to the bottom of the page. So let's do that. All the way here. Now, the reason why we want to do that is when the browser sees a script tag, it blocks rendering. Okay? Some browsers do. So we always want to keep our scripts at the bottom because we want the page to render real quick, and then the script can execute later on. The page load event is still fired at the same time, so you won't have a worse performance. But you'll have a better performance because your page is going to render faster. So we always want to keep our JavaScript at the very bottom of the page if we can. If we cannot, and a lot of cases when let's say you're building, working with a CMS system, or you have some user controls that injects style sheets JavaScript, then you don't necessarily control where they end up on your page, right? But try to get them as low as possible. It's best if you can put them just above the end body tag, but just rule of thumb, as low on the page as possible. If you cannot, for whatever reason, then there are some tricks to get around it. We can add some attributes here. We can defer loading. So defer loading means keep rendering. Render, even though the browser sees the script, it just renders over it. And then at some point, it's going to get the script tag. So this is really good if you cannot move it to the bottom. Another thing that's really good is async. This basically removes the entire script out of the running page, sort of. So this is the most efficient one to use the async. It will not always work because if you pull it out of the render cycle, it sometimes differs in what order the browser actually renders the scripts. So you may have jQuery first, and then you have your own file down under that uses jQuery, but you don't actually know whether jQuery is going to be running first or after. So there are some potential issues there. But, mileage may vary, but these are really, really good if you can't move the script to the bottom. Even if you can move the script to the bottom, play around with this async attribute. It's still good. Okay, so now when we go back in, we're at 95. All right, I got an extra point for moving my JavaScript to the bottom. It liked that, so that was good. So we're actually doing pretty well here. There are two things in Wieslow that are stupid. It tells us that we must use a CDN. I don't know about you, but not all websites, have access to a CDN. It costs money, and it might not be that important if your customers are all like in the same region of the world, for instance. Then CDN doesn't really make a big difference. But so we can safely ignore CDN. But of course, if you think that it would benefit you, then you should do that. And here's another one, e-tags. It basically says either configure them correctly or remove them. In the very old days of IIS, like IIS 5 or 6, actually I think it was 5, and before that, the way that the HTTP header e-tag was attached to an image was the wrong way. Right? They fixed that in IIS 6.0 a million years ago. Okay? No one runs something older than IIS 6, or at least I hope they don't. So this rule is stupid. It does not apply anymore, and they, for some reason, keep it here. So we can safely ignore that. Just FYI. So we're not going to get a better grade because we have these two. So 95 is actually pretty good. Oh, except we have a B here. I forgot to minify my JavaScript and CSS. So let's do that. So I have my bundle. And the cool thing about Web Essentials and bundles is that it automatically creates the min file. It looks like this. Right? So whenever I change any of my source files, the bundled file itself and the minified version of that is automatically recreated. So I actually already have this file. So all I have to do is to go back in here and say min. So that was easy. Let's just run this again. Ooh, 96. What about our JavaScript? So the modernizer is already minimized, so we don't really care about that. But we had our own script here. And it's living right here. To minimize this guy, to remove all the white space, and to rename all the variables and so on to A, B, C, D, really short names inside the functions and all that. Again, we can use Web Essentials, right-click, minify JavaScript file. And it automatically creates that for me. Whenever I change my script.js, the min file, and there's also a source map file, they will just be recreated just like we would expect. Okay? So our workflow doesn't change, but I now have a min file. So we'll just do the same. Min. Let's just delete the cache here. And we're really, really good now. Let's take a look at how far we've gotten. So we're now down to 55 kilobytes. So that's half of the original size. We're really good here now. There's not a lot more we can get from following the rules, but we can just look at this chart and say, is there anything we can do to make this just a little bit better? And one of them is actually something that PageSpeed is going to tell us about. Optimize our images. There are images here. It says that the one called fork.png, we could save a lot by optimizing it. Okay, then. Let's go do that. How do you optimize an image? This is really complex. When you get an image from your designer, or whoever gives you images, or if you steal them online or whatever you do, they might not be optimized. And by optimized, I mean all the palettes and bits and bytes inside the image is optimized. Not that you're losing quality of your image, but that we rearrange stuff inside the image to make it better and smaller. There are some good tools for that online. Smushit.com by Yahoo. Kraken.io, which is really good. That's my favorite at the moment. PunyPNG.com, also really good to minimizing our files. So now we have a workflow that designer gives us a file, and we upload it to this website that can crunch it, and we get it back. That's annoying. So let's use Web Essentials instead. So here are my images. So menu and fork, those are my two images. So let's just right-click these two. Web Essentials, optimize images. Boom. Two images optimized, total saving of 38.2%. So this actually runs the exact same logic that these online services runs as well. Okay? So it runs through, it will do PNG, GIF, and JPEGs. It will even do animated GIFs. Okay? So it uses OptiPNG and JPEG Tran and GIFsicle, all those command line tools. It's actually included in Web Essentials. So that's how we was able to shave 38% off just with a right click here. So let's jump back. Let's just clear the cache here. So Google is pretty happy now. It doesn't say anything about our images anymore. Notice, by the way, that Google could not figure out that the menu.png also needed to be optimized. It didn't figure that out because it's not as clever as Web Essentials. Okay? There are situations, though, where other tools might be able to compress more than other tools. So there are situations where you just compressed, you just did what I just did, right-click to say compress images, and then you go to PageSpeed or some online service, and they can actually compress it more. So because everyone uses sort of a different settings for all those minification tools, you just have to try it, I guess, and then you just take the smallest one. The key here is, though, that no quality was lost. It's the exact same quality. Nothing is lost, okay? This is a lossless optimization. And if we now look at our grade here, that's the same. But the stats are a little bit better now. Why didn't it? show, oh, those images were so small, actually. So let's just do that. So it's starting to be pretty good, 52. So now we're under half of where we started in terms of kilobytes. But there is one thing that I really want to do, though, because if we just take a look at this guy right here. So we have these two CSS images. So it's the menu, this little icon up here, and it's the fork mean GitHub ribbon right there. So only 4.3 kilobytes, that's pretty good. But the browser still have to make 2 requests to get these images. Now, there are ways we can get around this. We can create an image sprite. So if you go take a look at my talk at Build, I demoed, it's on Channel 9, I demoed how to create image sprites with Web Essentials. It's super easy. So an image sprite is where we take multiple different images and we put them into one large image. And then we use CSS background position to move to the right location. Right? So that means the browser only have to make 1 request to get all the images. So that's really, really smart. But there's another way, and I much prefer this other way. It's cooler, basically. And we can completely eliminate those 2 requests. Completely eliminate them. Okay? And it's something called base64 data URIs. Anyone here ever tried that? Oh, a lot of hands. Awesome. So what we can do is that we can actually take our small images and embed them directly into the style sheet. So how that works is we read the bytes of the images, we convert it into a base64 string, and we take that base64 string and put it directly into our style sheets. It's a little bit complicated, but let's see if we can figure out how to do that. So here's one image. So now I just need to go down and find it on disk and read the bytes and all that stuff, or I can just click here. And so now we have a nice little string here. Of course, you still get the preview. And yep, save, yes, bundle file updated. Here you see it in action. I saved my source file, and the bundle files said that they want to reload because they're open right here. We have one more here. Going to do the same thing. Notice that I can also optimize the image directly here. So you saw before I was going into the Solution Explorer and right-clicking the image. I can also do that directly here. But we already did that, so let's just base64 encode it. When it is base64 encoded and you say, oh, damn, I forgot to optimize it before I encoded it. Don't worry. We can also optimize data URIs. I think basically what it does is that it converts it back to an image and then runs everything on it and then puts the string back in. So it's the same sort of logic. But now we have this beautiful piece of base64 encoding right here. Okay? So that's why we can just collapse it. That's easier to read. So what? Update the image. Can we update the image when it's already a data URI? Yes. Because Web Essentials puts in a little piece of comment here. And that's not just for the fun of it. It actually uses, it reads that comment. So if you update the image, you get a new image from your designer and you put it in your solution, right? You want to re-embed it up here. So, yep, that's right here. Re-embed data URI from imagesfork.png. It needs this comment to figure out what was the actual path on disk, right? So yes, you can do that. But you can also save it to file. So if you receive a document like this, someone sends this to you, you can just say save file, and it will automatically give you like a save file dialog, and you can just save it, and then now it's a physical PNG on disk. So that's how that works. Okay, so let's go back here, reload this guy. And we got 97, so it liked that actually. But look at this. Now we're down to 5 requests. Just 5 requests. So we're definitely going the right way here. Now, this trick right here with the base64 encoded images, it works in IE 8 and above. If you're using IE 6 or 7, it doesn't work. So what do we do there? Let's just undo this guy. We can do this again. Okay. Now it works in all browsers. If you don't care about IE 6 and 7, you don't have to add this line under here, this guy, which is star background image. So what happens here is IE 11 comes in, or Chrome or something, and it says, oh, here's a background image, and this URL here is a data URI. I totally understand that, so I'm going to render it. Then it's going to go on to the next line, and it's going to say, star background image? What the hell is that? I'm going to ignore that. Right? All modern browsers will just ignore it, because it doesn't know what star background image is. Believe it or not, there's a bug in IE 6 and 7. So IE 6 is coming in. It's going to see, oh, I know what a background image is, but I have no clue what this thing is, so I'm going to ignore it. And then it's coming and say, oh, star background image, that's a background image. I know what that is. Right? So now you have support for both, and there's no side effects here. Okay, so it's starting to look really good here. Well, except for one thing. That fav icon, 32 kilobytes. Do you know the size of your fav icons? I bet you don't. I bet you don't. You get a fav icon, or you go to whatever online and get one there. And you've really checked the size of your fav icon? I don't think you do. I don't. Well, I didn't. I do now. But 32 is pretty big. But it's nowhere near as big as they get. Okay? They become much larger easily. You have to be very, very careful here. Hanselman, he had a funny blog post a couple of years ago where he figured out that a huge portion of the traffic to his blog was going to his fav icon. And his fav icon was like 75 kilobytes. Right? So there was a lot of traffic from that one file, and that was really stupid and expensive. So we want to minimize the size of our fav icon. It makes perfect sense. So to do that, we can use Visual Studio. You may not know this, but Visual Studio, at least 2010, but maybe before, actually have an icon editor. Do you know that? Mm-hmm. And we can see, this is how icons are built up. An icon is just not a PNG or a regular image. It's built by several images, one or more. And we can see the different sizes. 16 by 16, 48 by 48, 64, and 32 down here. But they go up. I've seen ICO files with all the way up to 512 by 512. Right? All the different sizes and different bit, like 32-bit or 8-bit, and different rendering for different things. But in the web world, we probably just need the 16 by 16. Okay? So we want to get rid of these other ones, the larger ones, and of course they're heavier. So to do that, we'll just right-click and say delete image type. It's gone. We do that here. We do that here. And let's just save this. And now because we're playing around with fav icons, we clear the cache, we close the browser, and we relaunch the browser again. So now, we're down to 1.1 kilobyte. So check the size of your fav icons, okay? All right. So 23, so this is, what is this? A fourth of where we started? Below that. So this is really good. However, this website, it's the Web Dev Checklist. I don't actually update it that often. Maybe every 3 months I update it. I'll bet you that a lot of your pages don't update that frequently either. So would it make sense to cache the HTML as well? Yes. The answer is yes. Yes. Be careful, though, right? Oh, actually, before we do that, there's one more thing I want to do because I forgot PageSpeed has a problem with my HTML. It believes that I should save 2% of my HTML by minifying it. Minifying HTML means get rid of all the white space that we don't need. So let's do that. This is the area where this could be labeled as don't try this at home. Okay? In order for us to minify HTML, we have to parse it. Okay? We could do regex, but you cannot parse HTML with regex. It is not possible. Your mileage may vary, right? You can get a long way with regex, but you cannot do it fully. It's impossible. So that's dangerous. However, let's just do that anyway. So I have a whitespace module hidden somewhere right here. So this guy hooks into this is an IHTTP module, right? So it just hooks into some of the request lifecycle, pre-request handler execute. And I'm doing two things. I'm actually removing two tags. If you ever used Wiselow and been really annoyed about how to get rid of E tags, this is the way to do it. Okay? So we're removing a couple of HTTP headers that we don't need. Why would you tell the world that we're running on IIS? So let's remove the server header. And the E tag thing, it's all for Wiselow. It doesn't make any sense, right? As I said, this is a stupid rule of Wiselow. But hey, if you want to get 100 out of 100, you do this. And then we say here, okay, for all my CSS HTML files, add a whitespace filter. And what this guy does is that it runs some regex to remove any white space that are not needed, okay? Any additional white space. There are way more sophisticated ways of doing that. There's actually a NuGet package up there that does this for you, and I forgot what it's called. I'm sure you can find it. It's really good, actually. This is my version of it. This is a brutal version, but of course I have tested it on this website, so I know that it's okay. Okay, so let's just take a look at what it looks right now. This is just regular stuff, right? A lot of white space, though. Remember that each tab, space, and new line is a character that needs to be downloaded by the browser. Right, so we want to get rid of that. So I save my web config. Let's update this guy. And now it's just one long line here. Okay? If you have text areas or you use the pre-tag, HTML tag, this would completely destroy that. Okay? Because they're pre-formatted. So in those tags, enter and tab and space have value. But this completely ignores that fact and just brute forces the way through it. But I don't have any of those tags, right? So I'm good. I'm fine. This website, that's fine. So let's run Chrome page speed here again. Now it's very happy with us. All right. So in the olden days, when there used to be a little mark up here that would say what our score was, this would be 100 out of 100. Okay? It has nothing else to complain about. If we go to Wiselow, we get 98. And look, our content delivery network is only yellow now because we have fewer files that we send over the wire. So there's less reason to deliver it on a global scale on content delivery networks. Okay? And we end up right here. So 22 kilobytes and 5 requests. That's cool. Now, we're mentioning caching before. So the prime cache, the chart on your right, I still have to download the HTML. Right? So what I'm saying is I don't update my website that frequent. So I think if I let the browsers cache this guy for a week, that's fine. I update my website maybe every 3 months, right? So caching it for a week is fine. Not everyone has the scenario where this is possible, but you might have sub-pages or something like that where you can do similar things. So let's go in here, scroll all the way to the top, and do this. So this is how, so I'm using ASP.NET Web Pages. If you were using Web Forms or MVC, you could just use output caching. This is how it works programmatically. This works on all ASP.NET frameworks. So this is just a programmatical way to set output caching. So the first line here, set valid until expires equals true. What that does is that it's going to look at our expiration, which is now plus 7 days, right? I want to cache it for 7 days. And it's going to make sure that the cache is always valid on the server for those 7 days. So what it means is that the server will never regenerate the page on the server side, no matter what if the browser has it cached or not. So this is the output caching. This guy makes it output cached, okay? We're going to make it public, so this means that now it will also work on proxy servers. We could say that this should be private, then it would only cache in the browsers themselves, but not on proxy servers. But we like proxy servers. We want to cache as much as we can, so we set it to public. And I'm saying, hey, if I change the web config, I have a file dependency on my cache, so there's that. That's not important. What's important is these 3 lines. So now, we go up here. We reload our page. Yeah, we can't get over 98. That's okay. But you see here the E tag thing. Oh, there's still one. Oh, I bet it's... Yes, it's the fav icon. Perfect. I know what to do. $96? Well, Wieslow is a stupid tool, as I was mentioning. Oh, didn't it actually... What the style sheet file is not... What the devil is going on? I downgraded my CDN? Oh, okay. So let's actually just kill IS Express here. Let's try this again. Damn. Okay. Anywho, if you look at the right side, okay, so there's something wrong with the IIS Express. It doesn't treat this as a static file, which it should. The full IIS will for sure. But what we're doing now, if you look at the prime cache, is the HTML page is gone. Okay? So now everything is just living in the browser. So when the browser sends, it doesn't send a single request, except for this one CSS file that for some reason is singled out here. But this is another way of doing offline support, if you think about it. If you've ever played around with HTML5 application cache, the manifest cache, you know that's really, really difficult and painful to do. But you can also just do this. Just have the browser cache everything. You get the benefit there. So it's actually really good. We're now down to, it has 2 style sheet files. Oh, I know why. Silly me, silly me. Epa! Here we go. See, that was way better for demo purposes. 0 requests, right? Everything is eliminated, completely offline. The browser will not send a single request for at least 7 days, then we'll request for our HTML page, right? So we get that full online support. We went from 12 requests to 5, and from 107 kilobytes to 22. This is a huge performance benefit. And how much code did I write? Not that much. Most of it, the easy part, was all done in the web config. If you go to my blog, matschristensen.net, you'll see all the fingerprinting mechanisms. I have all the code up there. So there you'll find it if you want to play around with this yourself. And also all the URL rewrites and so on. I have a full page on, a full blog post on how to do cache busting this exact way. So with that, any questions? Custom web fonts, what about them? Yes. Should we optimize our custom web fonts like our WOOF files and EOT files and so on? No, do not put them, do not base 64 encode them because they're probably around 40 kilobytes each, and one browser only needs one type. Like all the modern ones only take WOOF, old IE takes EOT or TT or all the other ones. So if you embed them all, you're going to have a way larger payload that's not needed for all the browsers. Don't do that. How will this work with master pages? Really, really well. So what I just showed you here was just an index.cshtml, right? If I'd used in MVC a layout page or a master page in web forms, exactly the same things would apply. Exactly the same. Nothing changes. We can still put our whitespace module in the web config and all that, regardless of we're running web forms or MVC. That's all the same. Yep. Yes, sir. What does? How does search engine work with base64 encoded images? I do not know, to be honest. I don't know what they're going to do, if they're going to display them or... Sorry. Yes, sir. Yeah. So what about a web server that serves data to the client? For instance, if you have an AJAX call that's being... and then JSON is being sent back, for instance, right? A web API call over AJAX. Everything that can be cached should be cached. User data is not one of those things, okay? So secret things or user-specific things, do not cache those unless you can cache them per user, okay, if that makes sense. But anything that's static, like a list of countries, let's say that you get a list of countries in JSON, you should just cache that completely. Yep. And will gzip work with that? Yes, gzip works with any text-based file, any text-based. So JSON, XML, HTML, CSS, and so on. Yep. Yes, sir.
You worry about, like, you do this, you lose hit counts and stuff like that, being able to track.
Will you lose hit counts when you do this sort of stuff? Like, let's say you have Google Analytics on your page. Will you lose any of that stuff? No, you will not, because that's JavaScript. And JavaScript, even though it's coming from the cache, will still execute. So you're not losing anything. The Google Analytics, you're still hitting that URL. The browser is still executing and hitting that URL, and they do not cache, obviously. Otherwise, the whole thing wouldn't work. Right? So that still works. Yep. Yes, sir? How do we fingerprint images in style sheets? We can do that through an HTTP handler, so we can do that automatically. I have a blog post on how to do that, actually. But there's nothing in tooling that will help us because CSS is static, so we can't put fingerprint razor code in there, for instance. But we can write an HTTP handler that serves the style sheet that has the mechanism of just fingerprinting any image, just parse it and do that. So I have a blog post on how to do that as well. But yeah, you can't do it directly the same way as we do in HTML. Yep. All right. There's a oh, yes, sir. Uh-huh. Yeah. So the question is, when I base64 encoded the images, the weight, the total weight right there actually went up a little bit. We pay a penalty when we base64 encode because a base64 string is larger than the bytes on disk, okay? It's actually a lot larger, like 30% or so. But we gzip, and when we gzip, we also compress the base64 string, okay? So we pay a little penalty, 5–10% potentially. So how do we balance what do we base64 encode or what don't we? Any image that's relatively small, let's say less than 5 kilobytes, that's also part of your entire app. Think about the general layout of your website. Maybe you have some rounded corners and you have some logo and some whatever you use images for. Those are perfect examples because any page, a subpage, have those displayed. So in that case, it doesn't matter what page the visitor comes in at. Those things are being downloaded, and instead of sending all the requests individually, we can just embed them directly, right? So that's the perfect thing. Do not put JPEGs in there. Never ever take photos and base64 encode them. That's really stupid. Because they're huge, and you want specifically photos to be cacheable on their own. Yes, sir. How do you optimize for what? Oh, how do you find unused CSS and remove that? That is the question of the day. That's really difficult, actually. So typically, we have a lot of CSS, and how do you find out what is no longer in use? Well, Browser Link and Web Essentials together in Visual Studio 2013 have a way for you when it records everything you do. So you can click on everything, go to all your pages, click on all the buttons, see what everything happens, and it will then feed the data into Visual Studio, and it will give you a list in the error list of all the things that were not hit of CSS. There are other things out there. You can put a little JavaScript on your page that does the same thing. There is a Chrome or Firefox plugin called Unused CSS that will do the same thing. You still have to manually navigate around everywhere, but it's not a simple thing to do, unfortunately. Yeah. Say what? An update for the application? Oh, yes. I should add that to Web Essentials to make it easier. You're right. All right, I think we have one more. Okay, so there's the answer. Chrome DevTools also have an ability to help you out with finding unused CSS. Yeah. All right, one more. What happens if I do it? It would like that. Yeah, so if you use the CDN version of Modernizer, we might get a higher point in Wislow. You're right. Because if that CDN is registered with Wislow, if Wislow knows it's a CDN, that's why this whole CDN thing is a little bit stupid in Wislow. Because you can trigger it. You can just say your domain name is, or localhost is a CDN, and then voila, you get a perfect score. Last one. Can we make Modernizer async? No, because it has to execute before any of the page renders. Modernizer is special, right? So you have to keep it in the head, and you can't use defer async on that one. All right, thank you very much, guys.